All right, so we're going to do the second part of 2-1, 2-3. So there's a different lecture than yesterday. Hopefully you labeled yesterday's notes as part A. If you didn't, make sure that you do that. So 2-1 to 2-3, this will be part B. So there's three different parts, excuse me, three different parts to your homework. So part 1, the directions are going to be something like this. State the first step in solving. The formula, or it could be an equation. For the given variable. So all of these have that same set of directions. So example 1. All right, so here's your equation, 1/2 x plus 3y equals 10. And you are going to be solving for x. So we're not actually showing the algebra, although in your notes I'm going to have you show the algebra. Bless you. And again, banana. It made you not sneeze, didn't it? It worked. So you're not, she's about to sneeze and I said banana. It worked, didn't it? So you're just going to write in words for the first part of your homework what it is you're going to do. So a couple things I want you to get used to. I want you to get used to putting a line where that equal sign is because it separates the left and right side and makes you think about what you have to do to both sides. So if I'm solving for x, find the variable term that has x in it. And isn't that where my x is? So my goal is to get that x by itself, or this term with x in it, the 1/2 x by itself. So if you look at this, ignore the right side because we don't really care what's on the right side. And if I want this by itself, what's in my way? 3y. How do you get rid of 3y, Sean? Why don't you put your backpack down so you're not quite so comfy and sit up straight. There you go. So, how do I get rid of a 3y? Yeah, isn't it a positive 3y? Isn't it being added currently to that term there? So to undo addition, don't you subtract? So in words, you're going to say subtract 3y from both sides. And I do want the words from both sides on there. So for our purpose, for our notes, I'm going to go ahead and have you do it, but this is all you have to do for the first part of your homework. You don't have to do what we're going to do right now in your homework, but I want to get you started for the next section. So if I were to subtract 3y from both sides, I would have to show it to both sides. And then the 3y's cancel. What am I left with on the left? Yeah, that's the only thing left. So I have 1/2 x. The equal sign doesn't go away. And then are these like terms? Do they both have a y? No. So I can't combine them. I can't make it 7y. I can't make it 13y. I can't multiply them because we're adding. So I've got, or technically in this case, subtracting. So I have a 10 and a minus 3y. So after we subtracted 3y from both sides, that's what we would have left. Did we solve for x yet? No. So there would be one more step, but you're not responsible for that yet. Okay, let's look at example 2. This time I have something fairly simple, 3ab equals 8. And you are solving for b. So again, there's my cut between my left and right side. here's where b is. That's what I'm looking to solve for. Do I have the term with b on one side by itself? Is there any other term with this? Terms are separated by addition and subtraction signs. Are there any other terms? Yeah. On this side? Oh, no. No, 3ab is all one term. So I do have it by itself, don't I? So ignore what's on the right. Look at that b. What's happening to it?
Multiplication.
Yeah, so how are you going to do multiplication? Very good. So we're going to divide this side by 3a and this side by 3a. And then words for your homework, you're going to actually write divide both sides by 3a. And then this is what we would have left. In this case, I have b equals, can 8 be divided by 3? No. So you leave it in fraction form, 8 over 3a in the bottom. Do not change it to a decimal unless there's a decimal in the original problem. We actually solved for b this time, didn't we? Mm-hmm. So this time only took one step to solve for b. The example above it, we haven't actually solved for x, so I didn't put a box around it. All right, example 3. So I've got 3/4 x equals 7y. And you are solving for x. So there's the cut between my left and right side. Here's my term that has the x in it. Is that term on one side all by itself? Well, it's the term that's on one side by itself, right? X is not by itself, but the term that has x in it is, isn't it? There's nothing being added or subtracted to this, am I correct? I don't want to see anybody leaning on their desks. When you lean on your desk, what happens to your diaphragm? It squishes, which means what happens to the oxygen? You have less oxygen going to your brain. When you have less oxygen going to your brain, what happens? Gee whiz, you fall asleep. So if you, no. I could make a stand. So I don't want you leaning on your desk. So when you get to college and if you lean on your desk like that, and then you actually have the gulp to fall asleep, your professor is going to ask you to leave the class and not come back. So you need to learn that, not to get embarrassed like that. Don't fall asleep in class. So don't even start the process. All right, so that term is by itself, right? So ignore what's on the right because I don't care what's on the right-hand side. I'm focused solely on that x. We've had fractional coefficients before. What do you do to solve? Everybody, what do you do to solve?
Times by 4 over 3.
Okay, so over here you're going to put multiply both sides by the reciprocal.
Could you say multiply both sides by 4 over 3?
Whoops. Yes, you could. Isn't the reciprocal 4 over 3 as Hannah said? So we're going to multiply both sides by that 4/3. So remember, multiplication is to the left and to the right. So I'm going to multiply that side by 4/3. It's the only one that is not done below. And I'm going to multiply that by 4/3. I'm putting the 7y over 1 because I'm multiplying it to a fraction. The 3 and the 4 cancel. Aren't you left with an x equals now? Does the 3 cancel into the 7? Nope. Does it cancel into the 4? Nope. So then just multiply across. We've got 7 times y times 4. What is that? 7 times y times 4. The only thing you can multiply is the 7 and the 4, right? So you got 28y over what's 1 times 3? 3. Didn't we actually solve for x? There you go. You're just manipulating. The last question in this section, as I'm losing my voice, this time I have 6x minus 3/4 y equals 10. And you are solving for x. So The term with x in it is here. So this time I want you to do it all by yourself. Well, just think about the first step. Remember, this is a separation of your left and right side. So I want you to think of that first step. What is it that you're going to do to both sides to get that 6x by itself? Say that again. Because the directions say state only the first step. So you're not going to finish this one. So they only want you to think about what's the very first step. In the next section, we're going to do all the steps. Hey, Brian, what's wrong? Brian, what's wrong? Okay. All right, so what are we going to do for our very first step? Are you dividing by 6, or are you going to add something? Hannah? Yeah, shouldn't we add 3/4 y to both sides? Because we're trying to get that 6x right there all by itself. Whenever you move complete terms from one side to the other, you're either adding or subtracting. We would never ever multiply or divide to move a complete term. So what do I have left on the left side? 6x. Are these like terms? Nope. So I've got 10 plus 3/4 y. I'm not going to put a box around it because I actually haven't solved for x. Any questions on that before we do the whole thing? All right, so that was baby steps. So can I flip this? Okay. All right, so example 5. Your new directions are solve each equation, slash formula for the variable indicated. So you're not going to actually get a number answer. You're going to get an answer that has variables in it. And these ones are going to look a tad bit more difficult. So example 5, and some of them are from your physics homework. This is an easier one. 1/2 times A minus B equals C, and you are solving for B. So we're doing the whole kit and caboodle. There's my B. So this time I'm not making you tell me, I'm just wanting to see it. So get in the habit of putting that straight line down from the equal sign. The equal sign should not move right or left. It's a brick wall. I want to get that B by itself, but what's in front of the B? A negative. So that negative belongs to the B. The negative does not belong to the 1/2. So I want to keep that negative B on this side. I'm ignoring the right side. What do you see? 1/2 A. How do you move 1/2 A? What's the opposite of a half A? Minus 1/2 A. So you're going to subtract a half an A from both sides. So minus 1/2 A minus 1/2 A. What do I actually have left on the left? I do have a negative B. The negative has to stay with that B. And on the right, these are not like terms. Can't combine them. So I've got C minus 1/2 A, because the negative belongs to the 1/2 A. Question. Because I'm not done yet, right? I haven't solved for B. So why is it that I'm doing that? How did you do that? Okay. Technically, what's the coefficient in front of B? It's a -1. So a negative in front of a number means that I actually have -1 in front. And so she's multiplied everything by -1. If I multiply this by -1, I have to multiply every single term by -1. The other way you can do this is it's really being multiplied by -1. So how do you undo multiplication? Jesse James, you taking notes? Okay. So you could divide, right? but I have to divide each and every term by that -1. Sometimes you're going to see me dividing the entire side by -1. It just depends on the problem. So watch as we go through when I divide the entire side by something versus when I do it individually. And so I do end up with a positive b. It ends up really just changing my signs. This becomes a -c, and this now becomes a positive 1/2 a. Have I solved for positive b? Yeah, so box it out. If you don't like having the -c in front, you could switch these terms around so long as you have 1/2 a minus c. Yeah. Is it an emergency? Can you wait? Okay. All right, so then example 6. Oh, maybe I need a different color. So example 6. This time I have something more complicated. Delta t times a is equal to v sub f minus v sub o. All of that is divided by delta t. Oh, oops. Is that what I wanted? Scratch that delta t there. Okay, can't read my different colors. That doesn't belong. Oh, yippee skippy. My whiteout doesn't work. I'll probably break that too. I'm really good at it. Alright, so that's going to be good enough. Thank you though. Okay, so it really should be A equals V sub F minus V sub O. That's all over delta T. So A is on one side, and then you are going to solve for V sub O. So here's my V sub O. What's the matter with it right now? What's wrong with it? What do you see as an issue? Yeah, delta T is underneath it. In other words, isn't it in a fraction?
Yeah.
Okay, we need to get rid of that fraction. So the very first thing that we're going to do, and if I were you, I'd write yourself a little note, you need to get rid of the fraction. How are we going to get rid of a fraction? Joshua?
Multiply both sides by delta T.
Yeah, see what the denominator is? Whatever that denominator is, if I multiply this side by delta T over 1, won't the delta T's cancel? Mm-hmm. And if I multiply the right side by delta T, then I have to multiply the left side by delta T. And I'm not putting this over 1 because A is not a fraction. So my delta T's cancel, and I am left with delta T times A. You can put that in parentheses, you can put a dot there, however you want to show it. You can just smush them together. I just want you to understand that delta T is one whole number, and A is one distinctly different number. And then you're left with, on the right, V sub F minus V sub O. So this is what I'm still solving for. Now what do you want to do? Do we want to add or subtract? What does this negative belong to? The V sub O. So do yourself a favor. Divide out your left and right side. Ignore the side that your variable is not on. So I'm going to cover that side up. I don't want to look at it. Then cover up your variable itself, including any sign that belongs to it. What do you see? A positive V sub F. So how do you get rid of it? A negative V sub F. So because the V sub F is positive, we want to subtract V sub F from both sides. So your second step here is to subtract V sub F to get negative V sub O by itself. Then are these like terms? No. So the V sub F's on the right cancel. My delta T A is positive, so I like to put it first. So delta T times A, then minus the V sub F equals. What's left on the right side? What's left on the right?
Negative v sub o.
Yeah, a negative v sub o. Have we solved for a positive v sub o? No, so how did you learn how to fix that? Yeah, you can either multiply or divide both sides by -1. Either way will work. I'm going to choose to divide. And then that essentially changes the signs of everything. So the delta t becomes negative delta t times a. The negative v sub f becomes positive v sub f. And then the negative v sub o becomes a positive v sub o. And if you wanted to move around the v sub f and the negative delta t, you could. But make sure the negative stays with the delta t. So that was a little tougher, right? But it was still, this time it was 3 steps because of negative v sub o. So if you take it baby steps at a time, it's been very similar. This one, this was your extra step, get the fraction. Get rid of that fraction. So that's something new. But this step was the same as what we've been doing. Add or subtract a term. And then this step is not new anymore. Get rid of a negative variable by multiplying or dividing by -1. All right, 2 more of these. Example 7. So these ones are on your own. Let's see how you fare. So example 7. This time you have v sub f again, but it's equal to v sub o plus g delta t. And you are going to solve for g. Yep, sorry about that. So there'll be 2 steps to solve. Bear in mind everything that I've taught you. So focus on that g. Pay attention to your left and right side of the equal sign. Get that term that has the g in it on one side by itself first, and then solve for g. And we can get it back over. If you guys are doing something for another class in my math class, that's what I typically will do with it. I'll rip it up. This is math. All right, so what's your first step? Yeah, if I don't care about this side because it's not the side where my variable is, then cover up the term that has your variable in it, including its sign. I need to get rid of that. Because I need to get rid of that, we're going to subtract v sub o from both sides. Even though these both are v's, are they like terms? No, because one is a sub f and one is a sub o. So v sub f minus v sub o equals g delta t. Should I crack the back? Ooh, yow. All right, so then here's our g. What's happening to g and delta t? What operation? Multiplying. How do you undo it? Divide by delta t. Now this is one time where you can divide this whole side by delta t. You could do it separately, and I'll show you what that looks like. Bless you. So one answer is v sub f minus v sub o, all divided by delta t. That's what g equals. So this is one solution. Or, if you divided each of these separately, then you're going to have g equaling this over delta t. So v sub f over delta t minus this over delta t, v sub o over delta t. Either one is acceptable. You might only see one of those answers online, but these are the same. All right, last one of this section. Example 8. Delta y is equal to v sub I t plus 1/2 g t squared. And you were solving for v sub I. So again, note the left and right side. Pay attention to the variable that you're solving for. Move any terms that don't have that variable in it to the other side, and then solve for v sub I. There are 2 answers to this one as well. Compare your answer with at least 2 people around you. When you're done. Just start talking. If you're stuck, ask somebody next to you what they did. Watch what I do up here. Okay, look up here. So if this is what I want to get by itself, I want to get rid of 1/2 gt squared, right? To get rid of it, don't I subtract it? Isn't that its opposite sign? And then I subtract it from the other side. If you had trouble, you need to follow along with me and write down what I write down. Aren't these opposite? Don't they cancel? Okay. So then on the left, so I'm dropping tens. I've got a delta y minus, because this is negative, 1/2 gt squared. The equal sign doesn't move. And I have v sub I t left on the right. It looks complicated, but all you did was move one term from the left to the right, or from the right side to the left side. Hannah? Right, I'm not done yet. Yep, we got one more step. So then we're solving for that, correct? What's happening to v sub I and t? What operation? Multiplying. So again, we're just dividing here. The easiest way for you would be to divide this whole side by t and leave your answer like that, so the t's cancel. If I were you, I would leave my answer as delta y minus 1/2 gt squared all over t. That's what v sub I equals. I would leave it that way. Did anybody divide these separately by t? Anybody? If you did, this is what, the only difference is this is what it would look like. Or v sub I would equal, take this and divide it by t, delta y over t, and take this and divide it by t, minus, and this is where it looks a little ugly, over t. Technically, this is not fully simplified right here, but we haven't talked about integer rules in here yet, so I'm not going to mark you off for that yet. We'll talk about integer rules later. But those are your 2 answers. This is the answer I would prefer to see. Okay, so how'd you do with that? Okay, so not so frightening anymore, right? Okay, all right, so then the last section should be easier for you. It's just 1 and 2, well, really just 2-step equations. So it's no longer formulas. So your directions to this section would be solve each 2-step equation. Show all transformations. needed. Needed according to my world, not yours. If you're doing it in your head, it needs to be on paper. All right, so we'll start out easy. This is something you should be able to do already. So am I on example 9? Is that right? Okay. So example 9, we've got 3x minus 8 equals 4. So again, here's your left and right side of the equal sign. There's only one variable this time. So isn't this the term that has my variable in it? I want that by itself. What do you do to both sides? Add 8. So we're going to add 8. Add 8. See how easy these are compared to the formulas? This is like a piece of cake now, right? The 8's cancel. Aren't you left with a 3x on the left? And 4 plus 8 is 12 on the right? Now what do you do? Easy, right? Divide by 3. And what does x equal? I have to see this. I have to see you finish it. X equals 4. That'll be one of your points. If you don't finish it, you're going to lose points. So don't be lazy and just say equals 4 off to the side. Then your homework's going to say this, check. And I don't believe the answers are there for the check. On another worksheet they are. But here's what your check is supposed to look like. You're supposed to take your original equation, and instead of x, use substitution parentheses. So instead of my x, I'm putting parentheses. What am I going to put in place of the parentheses? Yeah, your answer, 4. Then all you have to do is do the math. You're not trying to solve anything. You don't move anything from side to side. Do that math. Do it in the order of operations. 3 times 4 is 12. Minus 8 equals 4. 12 minus 8 is 4 equals 4. Does the left side equal the right side? That's what I need to see. If the left side doesn't equal the right side, either you checked it wrong or your answer is wrong, one of the two. And you only have to do that on, I think, 4 or 6 of the problems. Justine?
You have to see the 4 equals 4 as well.
Yes, that's the important part of your check. I don't want you jumping from here to here, mind you. I need to see that interim step. It's like a mini proof. You guys are going to geometry next year. This is your mini proof to me that your answer works. And then later on, you'll get to do it in your head. You won't have to write it down. All right, so example. Yes, this is your proper check written out. So if it says check, you don't get to do it in your head. You have to write this down. Later, you'll get to check it in your head. All right, so example 10. This time we have 1/5 x plus 2 equals 10. So again, note your left and right side of your equal sign. This is what you're trying to get by itself. Solve it. And check it. Check your answer with people around you. What do you do for your last step here? Focus on your variable. What do you do? Multiply by the reciprocal, right? Which is 5. So don't I get x equals 40? Okay, let's check it. So put 40, and I'm going to put 40 over 1 because I'm multiplying 40 to a fraction. Now, should I do 1 times 40 over 5 times 1 is 40 over 5? What can I do instead? Yeah, cross cancel. So 5 goes in here once, and in there 8 times. So I'm going to physically write down, oh, that's 8 plus 2 equals 10. 10 equals 10. That's the check I'm looking for. The last two, I'm not going to make you check. And these are completely on your own again. Example 11. You had this on your last test, but some of you skipped steps and or got the wrong answer. And so we'll talk about what can go wrong on this one. And then your last one, when you're done with that, Since this last one has a decimal in it, can your answer have a decimal in it? Just yes for once. So this is a decimal answer. Question.
It's easier for you to flip, like example 1, you flip it, make it 2 minus x equals 16.
Yep. As long as when you flip sides, you don't change the signs. All right, so go ahead and solve those. There are 2 ways you can solve the first one. Remember, when you add and subtract decimals, you have to line up decimal points. All right, compare your answers with those around you. All right, so here are my answers up here, and then I want to talk about both of these. Both of these can give you some issues. So a couple things I'm seeing that some of you are doing that I marked wrong on your test. One of the things I'm seeing is number 1 here, because the division is a little bit more difficult, I'll see some of you doing this. Instead of dividing in a fraction form, you're dividing like this. This is how you're showing your work. Is this how I've ever demonstrated it? No, so you should be doing this scratch work somewhere off to the side. If you can't do that in your head, don't muck up your equation solving with that. So that's one issue. And then over here, you could have solved it differently. And this is where, notice that I decided to add x to both sides first, so I would have a positive x, right? So I avoided having to multiply or divide by a negative. If you chose instead, couldn't you have subtracted 2 instead first? And so here you would have been left with a 14 equals. The 2's would have canceled. Wouldn't you have been left with a negative x? Some of you on your test, you stopped there and said that's the answer. What's wrong with it? Yeah, you solved for a negative x. When in reality, you should have divided both sides by a negative 1, and then you got 14 equals x. So watch it. Give you your homework, if I can ever stop this. Yay.